On today's episode, automakers have lost their minds. 400 plus horsepower? Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Way back in 1964, at the beginning of the NASCAR season at the Daytona 500, a promising young driver named Richard Petty showed up with a Plymouth powered by an engine that would become legendary, the 426 Hemi. Chrysler's Hemi V8, called that because of the hemispherical shape of the combustion chambers, ran away with that race and became so dominant that NASCAR actually banned the engine for a time in 1965. The word Hemi became synonymous with horsepower, and Stellantis still uses it today in marketing high-performance engines. The carefully race-prepared, custom-made Hemi in Richard Petty's race-winning car in 1964 produced slightly more than 400 horsepower. Now, it made that power with no regard whatsoever to engine wear, fuel consumption, or, of course, emissions. Now, you could buy a limited number of Hemi-powered street cars as well in those days, but they produced far less horsepower. Fast forward to today. You can buy a Hemi-powered Dodge today just as you could in 1964. Of course, today, the engines are hobbled by strict pollution controls and must be durable enough to withstand the long powertrain warranties commonly offered by manufacturers. And in today's engines, they need to generate reasonable fuel efficiency to avoid US government penalties. It's reasonable to expect that with all these constraints, today's engines would be somewhat less powerful than the originals. Except horsepower has gone the other way. A modern Charger Hellcat generates over 700 horsepower in street unmodified trim. That's with full emission controls, good engine durability, and reasonable economy. In rough terms, engine power has essentially doubled over the last half-century for the same displacement. Why? Well, it's been a combination of several factors, but critical ones are multi-port fuel injection, computer feedback control of fuel mixtures, variable valve timing, and the development of new materials for castings, bearings, and valves. For smaller engines, it's been about forced induction, mainly through turbocharging, but with a significant number of factory superchargers as well. Now, it took 400 horsepower to win Daytona in 1964, but that figure is commonly seen under the hoods of SUVs driving the kids to school on Monday morning. And it's not only incredible that this kind of power output is now common, but that it's actually mass-producible. It's hard enough to mass-produce automobile engines that withstand the EPA durability requirements for emission controls and can survive long enough to avoid warranty claims in an industry where powertrain warranties sometimes reach as far as 5 or 6 years. But to do so with a significant increase in horsepower is frankly remarkable. I once raced a 1976 Chevy Camaro with a 5-liter V8. It produced something on the order of 165 horsepower. I drove to the studio today in a 4-cylinder Honda that produces the same horsepower normally aspirated. And despite higher operating temperatures and much higher typical engine RPMs, the Honda engine has lasted twice as long as a typical street-driven cast-iron V8 of the mid-70s. Oddly, however, what hasn't happened is the use of all this high horsepower technology to allow much smaller engines to propel larger, heavier vehicles. I used to tow that 76 Camaro with a 1985 Ford F-150, which was powered by a 5-liter straight-six engine with a single-barrel carburetor. It produced 122 horsepower with 255 foot-pounds of torque. Now that's significantly less horsepower than my wife's Mini Cooper, but it hauled and towed just fine. But it went between 10 and 15 miles for every gallon of gasoline doing it, so you would think that modern pickups would use something like a 1.5-liter or 2-liter 4-cylinder engine combined with 10-speed transmissions to deliver the same performance with much better fuel efficiency. But that's not what's happened. Instead, we have a horsepower war in street vehicles as well. A 2022 F-150 uses a base 2.7-liter turbocharged V6 that generates 325 horsepower with 400 foot-pounds of torque. Fuel mileage is between 20 and 25 miles per gallon. More power and better economy. But I have to wonder, how economical could the unit be if it was designed to deliver horsepower and torque figures similar to my 85 F-150? 35 miles per gallon, maybe more? We'll never know, because electric vehicles will soon take over the market, and we'll be measuring efficiency much differently then. But in the half-century of development that I just described, consumers have opted to choose horsepower over fuel efficiency in almost every automotive product. And for street use, I have to wonder why. Well, that's it for today's episode of End of the Line, brought to you by Engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.